academic 9.6 notes. All right, here we go. So this week, we're going to learn the properties of logarithms. So we kind of like learned what a logarithm is the last class, right? What is a logarithm? Converting logs to exponents, to exponentials. Converting exponentials to logs, common logarithms, evaluating logarithms, and change of base formula, okay? Because that's what we added to your repertoire. That's class. This class, we're going to add more stuff to your repertoire. Okay? So the first one's called the product property. So if you have a logarithm and you have two numbers multiplied together inside the logarithm, that becomes the log of the first factor, so just that m, plus the log of just that second factor. So log of a single product becomes a sum of two different logs. All right, and this is really important, guys. We're going to use this formula in both directions, if that makes any sense. We're going to condense. We're going to condense logarithms, and we're going to split them up. Okay? We're going to split them up like Taylor Swift and Juno. Is that Alwyn? Is that his last name? What's his last name?
Alwyn.
Alwyn? Yeah. So, where have you been? Everybody loves it. I will not tolerate people saying bad things about you.
No, not bad.
She knows how to pick up. Okay? So let's do this first one. This first one's going to become log base 2 of 7 times 4. Right? So 2 logs. Note they have to have the same base too. Don't let them trick you with that. They're going to try to throw a curveball. Don't let them trick you. Okay? 2 logs added together, if they have the same base, we can just make it 1 log and multiply the 2 numbers. So it's log base 2 of 28. That's the answer. Cool. Awesome. There we go. That's why they pay me the big bucks. All right. What's up?
Do we have to put it in parentheses?
Yeah, you got to put it in parentheses. It's a good idea. Okay. This one, what does this simplify to? Do they have the same base, first of all? Yeah. What do they simplify to? Like 100? Okay, so we're doing all right with this. We're doing okay. All right, just got to gauge where we're at. All right, and then number 3, first of all, do they have the same base? Okay, so what do they condense to? 8x cubed. Cubed. Okay, how are we feeling about those 3?
Or is that the final answer?
Yeah. Just grab circle it. All right, can I move on to number 4? Is that too fast? All right, moving on to number 4. All right, so we're gonna expand. Okay. So what are 2 factors of 6 I can write now? 3 and 2. Great job. So this is the same thing as log of 2 times 3, right? Then how do I split that up? Log 2 plus log 3. All right, so we're just gonna lob you some, right? Just gonna give you some. Strawberries. Get some news with these. A little bit of batting practice. Then we're going to just slowly, pick up the spin rate. Take speed. I'll make an analogy. This next one. What are 2 factors of 45? 9 and 5. So this becomes log base 7 of 9. I want to see the bases too.
Doesn't matter what factors.
No, I won't.
Which one's the answer?
These are really important. We do a lot of cool stuff with these. A lot of logs. You don't use your logs when you run with business class. Actually, maybe not high school, but college class. This one, okay, so here's what's going on here. 5x, that's the same as 5 times x, right? So what are my two logs going to be? There you go. Properties of logs. I love logs. Logs are the best. All right, okay. Gonna do a little more condensing, okay? If we had more time, I would derive the quotient property for you. We don't have time. Well, we do have time, but it's kind of hasn't really worked out so far this year when I'm trying to derive things. So I'll just show you how to use it, okay? So when you have a logarithm of something that's divided, okay, a number divided by another number, that can split up into two different logarithms. Okay, that's going to be log base b of the top number minus log base b of the bottom number. Okay, so make sure you do top minus bottom. Top minus bottom. I'll throw my voice. Hello. Okay. Okay, and again, we're going to use this formula in both directions. Okay, so we can use it to condense two logarithms into one or split up a logarithm, okay? This first one right here, what is this going to condense to? Log base 23. Remember, whichever number comes first is the top. Whichever number gets subtracted is the bottom. This is log base 3 of 3. And it says to simplify if possible. What's this logarithm equal?
Wait, how did you get the 3 in the parentheses?
The 3?
Yeah.
24 divided by 8 is 3.
Oh, so you just...
Yep. And what does that equal? What's log base 3 of 3? All right, little review. Here's how we do this. Okay, to evaluate a logarithm. Okay, I don't like how it keeps jumping around. To evaluate this, we draw an equal sign, right? We put the small number on the left with a question mark exponent, big number on the right. 3 to the what equals 3? 1, there you go. Little review. I see we did not spend our weekend evaluating logarithms. That's okay. I actually watched some calculus YouTube videos this weekend. I've really got to get in the habit of it. All right, guys, this next one, they're trolling you. Obviously, the answer is going to be what? It's going to be 0 eventually. First of all, my base is the same. So what does this condense to? That first number becomes the top, the second number becomes the bottom, and that's when I have a minus sign. Okay. This is log base 2 of 1. What does log base 2 of 1 evaluate to? 0. Okay. Very roundabout way of doing something minus itself equals 0. Kind of funny. Value number 9. 9. Okay, so what's going to be on the top of my fraction? It's going to be on the bottom. We're going to have log base 4 of that, okay? What's x to the 9th divided by x squared? X to the 7th. Oh, I need some water. Hydrated. My water needs some grease. Can I go into number 10 yet or no? No? Okay. Okay, expand using the quotient property. Here's, I think, the easiest way to think of this. Instead of thinking this as log base 8 of 4, Okay, what's going on? I want you to think of it as log base 8 of 4 over 1. Okay? And you can change that 4 over 1 to whatever you want. You can make it log 8 over 2, or it has to be an equivalent fraction. So maybe log base 8 of 8 over 2. Is that okay? And then what does that become? Log base 8 of the top number minus log base 8 of the bottom number. So if they give you a whole number and tell you to expand it using the quotient property, just write the number over 1. Don't make life difficult for yourself. Can I do 11? What's 11 going to be? There you go. And then 12, what is that going to split up into? Stuff. And then the last property is called the power property. This one might be the easiest one. Okay, I feel like using m and n in the same problem is not a good idea because sometimes it's hard for people to see the difference. So I'm going to change that n to a k, okay? Pedagogy. Okay. So the way this works is this exponent just moves and becomes a coefficient. It becomes k times log base b of n. You just move it around. And again, we're going to use this equation in both directions. I love it. I love this one. You can just make the exponent a coefficient, or make the coefficient an exponent, whatever you feel like. Okay? I can prove this one to you using the principle of mathematical induction if you want to come by during office hours sometime. Okay? So this one, right? I'm just going to take my 5 here, right? I'm just going to move it, make it become a 5 exponent. So it's going to be log base 4 of 2 to the 5th, which is log base 4 of 32. Right? It says simplify if possible. Okay. So again, how do we simplify this?
It would be 9.
Right. Equal sign, right? Small number over here with a question mark. 32, big number on the right. 4 to the what gives me 32. Here's how I'm thinking of this. So 2 to the what gives me 32. 2 raised to the what gives me 32. 5. 2 to the 5 gives me 32, right?
Oh.
And how do you get 2 from 4? What do you have to power? What do you have to power 4 by to get 2? 4 to the what gives me 2? 1/2, right? Square root. So if you can multiply those two numbers, you get 5 halves. Right? So if you take 4, power it to the 1/2, you get 2. And then if you raise 2 to the 5, you get 32. So it's 4 to the 1/2, then you take that number and you raise that to the 5.
Wait, how did you get 5 over 2?
I don't really expect you that. No, I didn't. What's that?
How did you get 5 over 2?
So if you take 4, you raise it to the 1/2 power, you get 2, right?
Yeah.
If you take that 2 in here, you raise it to the 5, you get 32.
Okay.
And then so multiply these two exponents. I don't think I expect you to do that. Right. This one, you just move the 7 inside. Log base 2 of x to the 7th. Okay. This one, what does this become? Not all at once. Log a to the 1/3, to the 1/3. What's a to the 1/3? Two. Wow. Okay, and then it says simplify as possible. You can't do this in your head. I don't expect you to do that. But how would you do it in your calculator? Wait, you would just plug that in your calculator. That's base 10 log. You just do log 2. Yeah. Right. Log 2. Okay. An irrational number. You can technically do that by hand. If you know how to do it. There's a way to do it by hand. It's terrible though. It'd be awful. Okay. It's 12:10. We're all getting antsy, aren't we? Yeah, let's do 12:45 and just do these last three
Just real quick, are you like a diehard Taylor Swift fan?
I'm not that hard. I don't know.
That's like her, I like her music. The only thing that I really have against her is that she rewrote like her first 6 albums just to spite someone. And then
Yeah, like the
find it
recording
really
thing
annoying.
seems kind of like she's like against like
Scooter Braun owning them.
she's against like the guy. Was that like who helped her get big?
That's
He
the
was,
guy
like,
who supposedly bullied her using like Justin Bieber, Kanye West.
Because I was gonna say like if you sign a contract, like hey, I will
Hey, you
utilize
own
your
master
talent.
rights.
Yeah, like so if you record this music for me, I will make lots of money off it and give you a cut.
And
Make
you
you
get-
rich. And like I don't understand like if you sign the contract, that's what you agreed to. It's like that's so wrong. Why did you agree to it? All those yeah.
And then why are you now rewriting them? Just
But if she's doing it to I don't know.
it's because I think she asked for them. They said no, and then they sold it to Scooter, who she like hates.
That's kind of crappy.
I think she's trying to say.
So she did try to buy it.
Supposedly she tried to buy them.
That is clever though.
It's kind of dumb though too, because she like
And it's
produced the stuff,
something that you found.
and it's like if every single artist could do that, why wouldn't they?
Yeah. That's a good point. Yeah, what if every single artist did that?
It's like,
The music
okay,
industry
you
would
sold the
collapse.
thing that I gave you the master rights to and everything, and I'm just gonna turn around and.
Yeah, I don't know. I don't know the situation. I walked through the door with you. And it was cold. Something that I felt like.
Maybe she'll quit of an artist of my record.
Yeah, what's up?
Oh,
Yeah, use the bathroom during lunch, people. It's not hard.
Oh, yeah. Is he that? It's definitely not his.
No one can use the bathroom during lunch. Or when they're standing in the hallway looking at their phone. Alright, here we go. Where's my iPad? Oh, it's plugged in. I can plug it in.
Maybe I should give her more time. I should ask her. I'm like, are you going to or something?
Well, take your tickets.
Well, my parents are not going to this. But,
Okay, here we go.
I know she was going to ask me to do it. If she's not going to, I might just go ahead and do it. I've never seen any good lighting.
no, I finished my running out. Oh my god.
However, you have to taste it. Does anyone here know to build it?
Yeah, we
No, it's not screaming. Oh, I got it. Alright, so this last three. Okay, how do we do this? It says expand using the power property. So what's going to happen? How do we do this? How do we do this? Yeah. Yep, so we just take that exponent and it becomes a coefficient. 7 log 2. Right, how do we simplify this? What does this logarithm here simplify to? Log base 2 of 8, what is that? Use your calculator, you should know. How do we do this again? Okay.
7 times 3.
Yeah, equal sign, small number, the question mark equals the big number. 2 to the what gives me 8. 7 times 3, which equals 20. Alright, so instead of doing 2 to the what gives me 8 to the 7, you can just do 7 times 2 to the what gives me 8. Yeah. It can't go out. Anyone ever seen 19 Girls?
Oh, yeah.
Okay, what am I going to do here?
What were you trying to say?
Nice. I love the active participation. That?
James has some in his car.
I don't put the 3 in, take the x minus 1. Fine. There you go, take it out. It says simplify if possible, you can't simplify this. So let's just leave it like that. Oh, you see this one all the time. All the time you see these. How am I going to deal with this one? Yeah, so with these first two, right, I took the exponent and made it a coefficient. Oh no, there's no exponent here. Or is there? What's the exponent here? This is log base 7 of w to the 1/2. That's why we had that little radicals chapter. So we do this stuff. And then it just moves out. It moves out. There you go. There you go. Okay, so gave you some. All right, Max, got the phone there. Can't do that. Can't do that. 16. So I gave you guys some strawberries, right? Gave you some coach pitch. That was coach pitch, right? Coach pitch. This, we went up to the big leagues. We went up to the big leagues. A little bit of double A. Start with double A right here. Okay, so now what's going to happen is we're going to use all four of the rules we've learned so far. Change of base, power property, quotient property, product property. We're going to use all 4 of those to follow these directions. They want us to rewrite as a single logarithm and simplify if we can. Okay. How am I going to do this one? Is it 6 times 9? What is it? There's a minus. It's going to be divided, but we have to deal with this 2 here. Okay? This is not going to be 2 times log 2/3. It is not going to be that. Okay? What we have to do, we got to get rid of that 2 first. How do we do that?
Distribute.
Yeah, there you go. Good job. Take this coefficient and make the exponent. So it's going to be log of 6 squared minus log of 9, which is log of 36 minus log of 9, which is, yeah, you only distribute to the first one. Yeah, because there's no parentheses. Which is log of 4, which cannot be simplified by hand. Okay? Questions, comments, concerns?
Why'd you divide?
I divided because look, what are you thinking? Were you thinking maybe we should multiply or add?
Yeah.
So I multiply when it's 2 things added together, 2 logs added together. But I divide when there are 2 logs subtracted. So down here, there was a minus sign between my 2 logarithms, so I got to do division. Okay. 2 logs minus becomes 1 log with a division inside. All right, here to here. So now I've got a log plus another log. So now I'm going to do what? Yeah, I'm going to multiply, but I got to deal with these coefficients first. What do I do with them? Yep, make them the exponent. So this becomes log base 4 of a to the 4th plus log base 4 of b squared. And now we're going to multiply into 1 logarithm. So when you do multiple rules at once, it gets a little harder. Questions, comments, concerns? Alright, cool. Alright, we're going to use which one here? We're going to divide or multiply? Yes, we're going to do what with the coefficients? Make them exponents. This becomes log base 4 of u to the 7th minus log base 4. What is that b going to be? B to the what? Why is it b to the 6th? Yeah, b squared cubed equals b to the 6th. So then it's log base 4 of u to the 7th over b to the 6th. There you go, my dudes. Questions, comments, concerns?
Why is it u to the 7th over b to the 6th?
Are you confused where this u to the 7th came from? The division symbol or the b to the 6th?
The divisions.
The division symbol. So when I subtract 2 logarithms, I divide, like, they're like, these are what called their arguments. When I divide these things inside them. Okay, that's just a rule. That's just a rule. When you subtract two logarithms, you divide what's inside them. Okay. This one, right, when you add 2 exponents, you multiply what's inside them. So this, just go in order, it doesn't really matter. Just let's start with the first 2. Let's combine the first 2 first and just ignore the third one. Just copy down the third one. Let's combine the first 2. Okay, what are these first 2 going to combine to? So they're separated by an addition symbol, so what are we going to do with what's inside them? Multiply. Okay, so log of base 2 of 60 minus log base 2 of 6. And then what's going to happen to these 2? Log base 2 of 60 minus log base 2 of 6 become what? 60 divided by 6, which is 10.
Where did you get the 60 from?
So I had to combine, so I have 3 logarithms now, right? So I just picked 2 of them, any 2, I'll just pick the first 2. And I wanted to combine those first 2. Right?
Okay.
What do we do when we add 2 logarithms? Okay,
We multiply.
multiply what's inside them.
Oh,
So 15 times 4 is 60.
Okay.
Nice. Okay, got you 23? It's all right here. All right, we got 3 logarithms again. So let's just combine the first 2. What are those going to combine to? Y plus 1/2 log base 3 of 49. What do I have to do before I combine these last 2? I think you're on the right track. I got to take that 1/2 and move it inside. Can't combine 2 logarithms if one of them has an coefficient. What's 49 to the 1/2? And then this is log base 3 of 28. Got a little tougher now, huh? A little tougher. It's not all fun and games. Party's over. Lunchtime's over, kids. Alright? Stings to sting. Alright, 24. 24. So what should I do first? Yeah, that's true. Let's distribute my guy. Alright, let's combine these first 2, but I gotta do what first? Gotta take that coefficient, move it inside. So log base 5, 8 to the 1/3. What's 8 to the 1/3? 2. What's 27 to the 1/3? 3. Alright. A little cheat code here. Notice that these 2 terms are the exact same. What does a number minus itself equal to? Which is log base 5. Maybe I should have done it the roundabout way for you guys. Alright, 25. Put it back. What am I gonna do? This isn't too bad. This is like 90-mile-an-hour fastball, not too bad. Standard. Yeah, so before we combine these 2, we gotta make sure we don't have coefficients, right? So let's take that coefficient and push it somewhere else. Inside, yeah. It's not gonna wrap it. Let's take the 4 and push it somewhere else. Let's take the key and push it somewhere else. So this is log, what's 4 cubed? So then what's my final answer? We subtract 2 log, we do what with what's inside of it? 5. Log base 2 of 2, what does that simplify to? Now you guys know how to do logs. You know, get your $16,000. This last one, what do I want to deal with first? Coefficients, right? Coefs. So I'm going to take these coefficients, move them to exponents, log 36. What's 16 to the 1/4? So let's combine these first 2. What are these first 2 logs? 36 divided by 2. Try again. And then the last logarithm. What does that combine to? 54, right? Ooh, why are you saying 6? Yeah. Good. Good. Okay, questions, comments, concerns on those? We move on. Now, instead of combining logarithms, we want to go the opposite direction. So like, now we want to take this and we want to write it as 3 different logarithms, okay? We have 3 variables, so 3 logarithms. Okay. What operation do I have going on inside that logarithm? X, y, z to the 4th. That's times, right? When there's no symbol, it's times. So I'm going to write this. I'm going to have 3 logarithms. Is it going to be sum, difference, what, of all the logarithms? Sum, right? When you have multiplication on the inside of a single logarithm, you can split that up into different logarithms added together. Log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. And then what do I want to do with that 4, that exponent 4, if I'm expanding? Take it out. Make it a coefficient. Now I'm done. Can I do 28? So I have how many variables here? 2. So how many logs am I going to have? 2. Am I going to write this as a sum or difference of 2 logarithms? And why? Difference. Why is that? Division, right? So it's going to be log base 4 of a to the 9 minus log base 4 of b. And then my last step here is what? Take out the 9. Take out the 9. Okay. There you go. There you go, kids. Row for that one. Now for 29, how many variables are there? Yeah, so I think I know what this means. It's a little ambiguous. So what I would do first is I would simplify these exponents here. How do I do that? When I have an exponent raised to another exponent, what does it become? What do I do with the 2 exponents? So I have an exponent on the inside of my parentheses to an exponent on the outside. How do I combine those? You don't add them. Multiply. Okay. Now it's a little better. I'm going to have how many logs here? 2, right? Because I have 2 variables. Are they going to be separated by a plus or a minus? Plus, right? Because there's multiplication. It's a multiplication symbol inside my parentheses. So it's going to be log 7 of QB8 plus log base 7 of r to the 4th. What's my last step? Take the exponent out, yeah. 8 log base 7 of q plus 4 log base 7 of 4. questions, comments, concerns? Okay, this one right here, what do I want to do first to make it easier on myself? Y over z to the fifth, a fraction raised to an exponent. How do I deal with a fraction raised to an exponent? What does that become? It does, yeah, but we want to get, so we want to distribute this exponent first. It's going to make our life a lot easier. What does that become? Y squared over z to the 10. So whenever you have like an exponent inside a set of parentheses raised to an exponent outside those parentheses, you multiply those two exponents. I did the same thing with y. It technically had an exponent of 1. Okay. And then, yes, it becomes log base 2 of y squared. Minus log base 2 of z to the 10th. And then move those exponents outside. So when you're expanding, the exponents become coefficients. When you're combining, the coefficients become exponents. So right now we're expanding. You feel okay about this? It's new. What do I want to do first? How do I deal with that square root? Yep, so change it to an exponent. Now remember, this is really important. Both the 7 and the x cubed are underneath my square root symbol, right? So they need to have, my 1/2 needs to be with parentheses. My parentheses need to go around both my 7 and my x cubed. It needs to be raised to 1/2, okay? You get the answer wrong if you don't put that. Okay, what do I do then with this 1/2? Yeah, I can move it to the front. So there's actually two directions. We can move it to the front or we can distribute. We can do either one first. Let's move it to the front because I don't want to do 7 to the 1/2. 7 to the front. I will say, we're going to move the 1/2 to the front. We have to remember one little algebra. Okay. So I move the 1/2 to the front. Then how do I deal with the logarithm? Log of 7x cubed becomes what? What operation is inside the log? Multiplication. So this becomes 2 logs subtracted or added? Added. So 1/2 log 7 plus log x cubed. What did I do wrong? I did one thing wrong here. Yep, you need parentheses. You need parentheses because that 1/2 gets distributed. This is 1/2 log 7 plus 1/2 log x cubed. Last step here is what? That 3 there needs to come outside and be a coefficient. So it's going to be 3/2 log x. All right, that was a toughie, right? That was a curveball. That was a curveball. That was a curveball. Maybe 32. How do I deal with that 4th root there? how do I deal with that fourth root? Comes log base 3, and remember your parentheses, m to the 5th, n squared to the 1/4. Yeah. What do you want me to do now? Yeah, so I can distribute the 1/4 and multiply these exponents together. That's kind of a pain in the butt, though. I can just, at this point, I can just move it in front. We can go either way. Now what do I do? Log of n to the 5th, n squared. What's that? Yeah, split it up. Plus or minus sign in between. Plus. Just make sure you do it in parentheses. If you forget your parentheses, wrong. Yeah. Okay, it's going to be wrong. So distribute 1/4. 1/4 log base 3 of n to the 5th. Plus 1/4 log base 3 of n squared. My last step is what? Exponents move to the front. Move to the front. So 5/4 log base 3 of n plus 2/4, or yeah, I'll just write it as 2/4 log base 3 of n. And then obviously 2/4 becomes 1/2. And I wanted to write it like that so you can see my thought process. All right, questions, comments, concerns. We have a nice little table here. Okay. We actually haven't talked about these. Log base b of b. You can evaluate that. What is that? 1, right? B to the question mark equals b. B to the what gives me b? 1. That's why that's 1. All right. B to the what gives me 1? Gives me 1. Okay. Cool. All right. This is just log base b of m plus log base b of n. This one is log base b of m minus log base b of n. This is n times log base b of m. Change of base, a little review from yesterday or Friday. Did I see you Friday? Yes. What can I rewrite this as?
You go back to the last two.
Yeah. What can I rewrite? Change of base. What can I rewrite log base b of a as? Log a over log b. Loga over log b. There you go. That's all she wrote. Do the homework for tomorrow. Ravioli, ravioli, give me the formula. Good work today, guys. It's getting a little tough, huh?